Okay guys, welcome to my YouTube channel. In this last three videos that I'm going to post, I'm going to talk about balancing redox reactions, and I'm going to talk about ample examples like usual so we could get the hang of it. Okay, so let's get to work and balance the first example without any waste of time. So this is the reaction as double minus. To do the redox balancing, you have to be very good at calculating the oxidation state of elements in compounds. Okay, usually it would be the non-metals or metals in these reactions that will change their oxidation states, but we have to be very fast and very skilled in doing so, and you will learn it as I do. So I assume that you go review the video on that oxidation states that we posted earlier, and then make sure you have good skills on that. It's S equals to the charge, so -2, and elemental, so 0. Nitrogen minus, because of the 3 minus 2, which is the oxygens always, so n minus 6 is -1, so n should be +5. And also n minus 2 is 0, because the charge is 0, the fifth becomes +2. So that's a change of 5 to 2, so 3 drops, and here a change of -2 to 0, so 2 rises. The rise and drops also has to do with the number of elements in the reactant side. If you have 0 or any other thing, if you have 1, then there would be itself, like here, and also here when we have 1, n1 and s1, which we don't write. If you have s2 or n3, for example, then you have to multiply those numbers with. So then we exchange these raising to 3. Like the green one I put for the nitrogen, so 2NO3, and 3 I put for the orange one I put for the sulfur, which is green. Then I go onto the product side and balance both of those, 3 sulfurs, so 3 sulfurs, and nitrogen, 2 nitrogen. We just balance the atoms that we just actually exchange their reduction oxidation changes. Okay, then if we don't have any hydrogen, we're going to balance the oxygens. Okay, and to do that, there's a set of rules. I will just write them down, but I don't want to actually keep it here on my whiteboard, but you could have it on a piece of paper. Even in a test, you don't need to memorize this. In the acidic media, if you need, let's say, X oxygens on your product side, it could be also on reactant side. Let's just assume it's on the product side. So you would start with the site that lacks the number of oxygens. We have not counted it here. We will do so in a real short time. X oxygens, you add X H2Os, and to the opposing side, because you have to compensate for the number of hydrogens, you add 2X of H pluses, okay? And with a acidic balancing because of H pluses. Also, if you want to do the same reaction, which needs X oxygen on the product side in the basic media, you add 2X, double the amount, like 2X of OH minuses, and to compensate for the hydrogens, you just do X of H2Os to the opposing side. That would actually compensate for the amount of hydrogens. At last, and we say the basic media, because you've used OH minus. So you could do it two ways. We will do both equations, any example we do. And after you do that, you just check your equation for the charge on both sides. If the charge is balanced, it means you've done a good job on your reaction. So for this, I don't have any hydrogens. I just need to count my oxygens and do it on the acidic media and on the basic media. I need to rewrite the same exact equation 2 times. For one, I would do on a basic media, and for the second one, I'll do for the first, I will do in the acidic, and for the second one, I'll do in the basic media. For the one on the top, which is the acidic media, let's just count oxygens first because we have not done so. If you have, and that would be the same because they're the same equation. So you have 2 oxygens on this side, 2 times 3, 6 oxygens on this, so you need 4 more here. that's what you need. Okay, and that would be the same for both. If I need 4, I would just do 4 H2Os here and 8 H pluses to compensate for that, and double the amount, like 8 OH minuses here and 4 H2Os to compensate. Okay, that's how I do it. And then let's just check the charges. So I have plus 8 minus 6 minus 2, so 0 and also 0, charges balanced. Minus 6 minus 2, it's minus 8. On this side I have 8, so minus 8, charges also balanced. So I have done a good job on this one. Let's move on to another example. Okay, it's good enough. And this would be Cr2O3 plus nitrate, giving me double minus and NO2 minus. Okay, that's one. And this is also a simple example, but I don't have hydrogens involved. Chromium to chromium and nitrogen to nitrogen. So chromium is 2 chromium minus 6 because of the 3 oxygens equals charge, which is 0. So 2 chromium minus 6 would be 0, so chromium would be then plus 3, each of them. Chromium minus 8 is equal to minus 6 minus 2, so chromium is plus 6. Okay, here nitrogen minus 6 is minus 1, so nitrogen is plus 5. And here nitrogen minus 4 because of the 2 oxygens equals minus 1, so it's plus 3. It's 2 of a drop here and 3 of a rise here, but 2 times 3. Okay, so if it's 2 times 3, we could then cancel these 2's and say 1 goes for chromium and 3 goes for nitrate. Okay, if that's the case, then we will have 3 nitrogens, also 3 nitrogens, 2 chromium, 2 chromium. Let's just get rid of this 1 here. And let's now count the number of oxygens. I have 3 oxygens here, also 9, so 12 oxygens. And I have 8 oxygens and 6 oxygens, so I would have 14 here. So I need 2 over here. Okay, if that's the case, I would like to go on and rewrite the reaction one more time. Okay, that's the reaction. Now I need 2 oxygens on this side. In the acidic media, it means 2 H2Os and 4 H pluses. In the basic media, double the amount, it means 4 OH minuses and 2 H2Os. Let's just check the charge on those reactions and then see if we could move forward and do another example. So here we've got 3 negative charges, and here we've got 4 negative minus 3 plus 4. So these two cancel out, 3 negative balanced. 4 negative charges minus 3 minus 4. Oh, my bad. Let's see, here is what an awful mistake. Here's the product side to the reactant side. So it's now 4 minus 3 minus 7, and also minus 4 minus 3 minus 7. So the charge is balanced as well here. Let's move on to yet another example. So for the next example, I would like to do this reaction. Arsenic O3 triple minus. Okay, let's do this one. Also no hydrogen involved, so it's still a kind of an easy case. We're starting with the easy, going to the hardest. Arsenic, iodine, I minus is -1, 2, elemental form is just 0. Arsenic is -8 because of the 4 oxygens. Arsenic -8 is -3, so arsenic is +5. Arsenic -6 is -3, so arsenic is +3. So 2 overrise here, and also, my bad, 2 of a drop here. I apologize for the mess, and 1 of a rise here. So we exchange these, we put the rise, and it's 1I and IS1, so we don't need to do anything, that's fine. The green one for the orange, so 1, and then the orange one for that, so 2 I minuses. If it's 2 I minuses, just 1 arsenic, so just 1 arsenic. Let's just, we don't have any hydrogen involved, so let's just count the number of oxygens and go on. So I have 3 oxygens here, and I have 4 here, so I need 1 on this side. Okay, that's what I need. I'll just go on, rewrite my reaction one time more. ASO4 triple minus plus 2 I minuses, giving me I2 plus ASO3 triple minus. Okay, for the acidic media, I just do 1H2O and 2 H pluses. For the basic media, I need to add 1 oxygen, so double the amount, 2 H minuses and just 1 H2O. Okay, let's just see if the charges are balanced and we're good to go. So -6 here, -3 and +2. It's -8. I don't know why I did this. -6. -2, -3 +2, so this would cancel out, so -3, also -3 balanced, -3 only, and let's see what is wrong. This is 2 minus, 2 I minus, so it would be -3 -2 -5, also -3 -2 -5 balanced. Let's move on. Let's see if I have enough time. Yes, we could do maybe 2 more examples for this. Let's go on to take 2 more examples. And on my last example, I'll probably get an example where we have H, okay? Let's do this. FeO3 minus plus I minus, giving me Feel minus plus I2. Iodine and chlorine are changing. Iodine is going from -2 to 0, and chlorine is going from chlorine -6 is -1, so it's +5, +5 to -1. From +5 to -1 is 6 of a drop, and from -1 to 0 it's 1 of a rise. So I put 1 for this chlorine here, and I put 6 for this iodine here. 6 iodine means 3 I2, and chlorine is just the same amount that I just have. Okay, let's go on. I don't have any hydrogens involved, so I go on and count my oxygens. I have 3 oxygens here and none here, so I have to add 3 to this part. Okay, that's how I do it. I would rewrite the reaction one more time to make sure I do have both acidic and basic. So to add 3 oxygens, I do add 3 H2Os and 6 H plus to this side. And for this one, I do double the amount, 6 OH minuses. To the side, I need oxygens and 3 H2Os. Okay, that would be the basic equation. Let's just check to see if the charge is balanced, and we can do one last example and wrap this section up. 6 pluses, 6 minuses, and -1 here, it's -1. Also -1 here, charge balanced, -1 and -6, -7, -1 and -6, -7 as well. So the charge is also balanced. Let's move on to the last example. And in this last example, I want to do one that contains hydrogen in it. Okay, so before doing oxygen balancing, we have to balance the hydrogens as well. Let's do this example. Selenium plus BrO3 minus gives me H2SeO3 plus Br minus. Okay, this is what I want to do. Let me just write down a little bit. Selenium plus BrO3 minus, just to have a little bit more space. Sorry for the delay. Let's go on. So bromine and selenium, both nonmetals are changing. Selenium go from 0 to Se plus 2, and -6 means Se minus 4 is 0, so Se is just plus 4, and Br minus 6 is -1, so Br is plus 5, Br minus 1. Okay, so that's this. Se is 4 of a rise. There's no underscript for it. Br is also 6 of a drop. So we could actually do 2 and 3 if we wanted to. Let's do that. We do 3 here for selenium and 2 here for bromine. If we just get rid of the 6 and 4 for 3 and 2. So we put the green one for the orange, so the 2 and the 3 goes for that. The bromium is going to be 2 bromium and 3 H2Se. Now we have hydrogen involved. That means I need to add hydrogens to the other side, so I do 3 H2Os here. Okay, let's just count number of oxygens. Okay, I have 9 oxygens here, and I have 3 and 2 times 3, 6, 9 oxygens. Okay, so for this example, you see that we have same amount of oxygen, so both the acidic and basic equation would be the same. 3H2O plus 3Se plus 2 BrO3 minuses, giving me 3H2SeO3 and 2 Br minuses. The charge, if you check, is just -2 here, -2 here, and for both equations you would have the same equation. You don't need to add any H plus or OH minuses because you have the same amount of oxygen. I'm going to wrap this video up here for the first session on balancing redox reactions.